Good morning, Tamina Khan is here in TKMaths is fun. In today's video, we will understand the concept of linear form. And don't get frightened by seeing so much text written here. It is for those who like to read literature on any topic. Otherwise, I will explain it to you. What does it mean? So when we are saying linear form, it means writing equation in this form, which is called y equals to mx plus c. Now when experiment is done and the data is collected for two factors, two variables. One we write on the x-axis, one on the y-axis. And the linear form equation passes like this. This point, which is called y-intercept, usually we write here y and we write here x. So the data which is on the y-axis, which intercepts here, is represented by c. And you know what is the importance of this particular data? For example, my x-axis is time. So it means when time was 0, when the time started recording, at that time what was the value here? Now your y may represent volume, may represent area, may represent height, whatever, right? So that simply means that when time was 0, what was the value here? So that's why linear form is always easy, because it immediately gives you many information. Similarly, m in the linear form gives you the information about the rate of change. Okay, so now in this chapter, basically we will learn how to change any non-linear equation into linear form. So what will be new in this chapter? Basically, your x-axis may have any variable. For example, it may have x square, you may have y square, you may have here x plus y, you may have here log x, you may have here log y. Similarly, all these could be here, not just y all the time. It could be anything, maybe x over y, maybe log x over y, maybe x square plus y square. So it could be anything. So we will see here, when we change any non-linear equation into linear form, what comes here? That will be your vertical axis. What comes here? That will be your x-axis. That will be your vertical axis intercept. I'm using the word vertical axis. Reason is because whatever will be on the y-axis, it will be called that axis. For example, I can say x over y. So, for example, I have here x over y and I have here log x. It means here I will have x over y, m will be some number, and here I will have log x, and this will be some number, for example 2.7. So I can say x over y is plotted against, you need to understand this language how to speak, because it is written in word problems in the past paper. X over y is plotted against log x. So this is the meaning of it. If I say x square is plotted against x plus y, you know what does it mean? It means on the y-axis you will have x square, and on the x-axis you will have x plus y. Okay. Now we have to see how to change any non-linear equation into linear form. First, I am showing you here two solved example which I have written, and then I will solve in front of you one or two equation. This is video 1. I will make 2-3 videos in which I will take different examples. So for example, we will study here two cases, polynomial to linear. So if polynomial equation is given to you, y is equals to ax power n, then how do you change it into linear form? You have to bring this n down here, right? It can't be in the power. And the only way to bring it down is to take log on both sides. Now here it is your choice. You take ln or you take log on both sides. So prerequisite of this chapter is the understanding of the log and exponential concept. I have made videos on that also. Link will be in the description, so you can see that. Then it is log bracket ax power n. How did I get this from here? By applying product rule. Log y plus log x power n. I'm writing here for your understanding. log a plus log x power n, and this n will come here and it will become this. So you see, this is your y-axis, this is your c-intercept, this is your x-axis, and this is your m. Why? This is only variable, only constant, and this term has both constant and variable. So that's why I know this is the term. Okay, I will take more example. If you're not getting, you will understand. Now this case is for exponential to linear. This one was polynomial to linear, and this is exponential to linear. Can you see the difference between the two? Which equation is called exponential, and which is called polynomial? What did you notice? See here, in this one x is in the power, and here x is not in the power, rather a constant is in the power. So just like you write here x square plus 2x, these are polynomial. So that's why the case 1 is polynomial, and we are changing it into linear form. Similarly, exponential we will convert into linear form. So again x is in the new power, so I have to bring it down. So I will take log on both sides, because there are two terms and one power, so we will write it in the bracket. Now this will act as a product rule. So I will say log a plus, what will I say? Log b power x, and then x will come here and you will get this. So I will show you their graph as well. I told you this is on the y-axis. You can notice here. On the x-axis I have log x, which is here, and this one is your c-intercept or y-intercept, so it will be log a here, right? Similarly in this one, this is my y-axis, log y. This is my x-axis, just x, it is here, and this one is my intercept, so it is log y-intercept. So I will write here log a, sorry. Now in this video I will just change this into linear form, so that